Whoa. Yeah, the volume is much louder than higher than I expected. So I'm really happy to be here talking about this amazing stuff about controlling smart homes with React Native. Let me just introduce myself. My name is Vladimir Novick. This is my Twitter handle. I'm a independent consultant. I work with various customers on web, mobile, VR, AR, and IoT fields. I'm also an author of a book, React Native Building Mobile Apps with JavaScript. And recently, I also co-founded a startup called Vscaper. We are location-based VR gaming experience, bringing VR to the next level, doing much more immersion than it currently is. You can check our website and subscribe for updates, and when we'll be live, you will be the first to know. So let's talk about smart homes. So currently, we all know that smart homes are out there like for several years. We have lots of things connected. We have lights. We have temperature, humidity sensors, various stuff connected to internet. And we can control everything, right? Sometimes we can't, but yeah, so sometimes there is that problem. But eventually, in an idealistic world, it all looks like this, right? The whole home connected to all devices connected, and we just work from one app. We start everything, everything works. But it's not really the case. The case is we have various apps, we have various devices. We have, for example, Philips Hue. We have Wemo. We have Chinese light bulbs, or various stuff out there. And every brand has its own app, has its own thing. And you need to coordinate everything inside one app. But APIs and protocols are really different. So let's take a look at three steps, I would call. The high price range, which is Philips Hue lights. This is this kind of light bulbs, bridges. We'll talk in a bit on architecture, how it works. There's Wemo, which is kind of mid-range. And there's a bunch of like LED strips for $7, $5 on eBay, on Amazon. You can buy from Chinese suppliers. And it has an app. Sometimes it controls lights, sometimes it doesn't. Who knows? But yeah, you can. It's a cheaper one, right? So probably if you want to put a light bulb for your inside your kid toy or something like that, you won't put the Philips Hue, which is high range. You would buy a like replaceable one or something like that. So if we look at Hue in general, at Hue's API, it works like that. It has a bridge. It's this kind of device, which connects to the internet, and it uses Zigbee protocol to connect to the actual light bulbs. Above that, it has remote API. API is pretty solid. And actually, you see right now, it's a small, but yeah, you see right now, this is the actual IP of this bridge. So I can actually connect to the Philips Hue service and get the IP on a local network, and it just works. Or I can even try to access the light bulb. And for example, I can get all lights, and I will see all lights out here. And I can do various things. I can, for example, change the state of the light. For example, it takes light bulb number 5. This is its ID. We'll change its state, and we will pass on true. And it won't work. I don't know. Ah, yeah. It has to be JSON, so. No. Will work later on, probably. Ah, it's put. Yeah. So you see? And we can even dim it, right? So there's another device which is basically this guy, little guy here. This is a smart electricity plug. You can plug anything. Like I plug this is a regular lamp. Nothing smart about her. So Wimo works in a very particular way. It uses UPnP protocol. It sends, you send SOAP messages. You get like setup XML that you need to send again. And you see, it's like really complicates the steps to make this thing work, right? And there is Magic Home. It's maybe called Magic, but it's like the cheapest one and probably not really much reliable. But hey, most of the time it works. So it works over TCP sockets on port 5577. And basically that's how it works. So the question is, we want to create one app to coordinate every one of these devices inside of it, right? But different protocols, reliability, and who knows what. So what do we need to do? We need to build our own bridge, right? Not this kind of bridge. Let's build something more reliable. But we need a little bit of hacking, because we have protocols, various protocols, so we need to find out IPs of devices and stuff like that. So there is UPnP protocol. UPnP protocol is a universal plug-and-play protocol that we can use to discover which devices are on the same network. We can get device MAC address. For some devices, we can check the back of the device, and sometimes there are MAC addresses. Sometimes there are no MAC addresses, so we need to figure it out somehow. And basically, from MAC address, we can, on local network, figure out the actual IP of the device. And then we need to sniff network. Yeah, the deep dive thing, so it looks like this. So we have these packets coming from this device, and we see that it goes to specific service that is called URN Belkin service. This is specifically to Wimo. And it's relatively easy comparing to the Chinese ones. Chinese ones, it's kind of a really deep thing. So we need to create, first of all, we need to sniff network while our phone is connected. So to do that, we create interface by running instrument. We're talking about mostly on Mac and iOS, but different techniques are also applied to Android. We can sniff packets through Wireshark. And we run instruments -s devices. Then we get some, from that call, we get some kind of ID. We run RVICTL with ID, if config, and then when we open Wireshark, we have the interface present, and we see that packets are sent over this interface. Again, everything when phone is connected. I know it looks like really deep dive, but there is a trick to that. So there is some fun part in the middle, close to the end. So bear with me with the deep dive thing. Why do I say that? Because now we need to figure out base 64 values. No, just kidding. We won't do it right now, but eventually you need to do to create like regular connection to this, understand how these light bulbs work. So we get the stream, then we follow the stream, and we get these ones. So this means a handshake, and this means turn device on. Don't ask me how I figured out. Just like, you just sit and start to figure out. But actually, there are libraries. There are libraries that does that for us. For Wimo, there is Wimo client library. For Magic Home, there's Magic Home library. They are at various stages of development. Sometimes they're reliable, sometimes they don't, but you can get these values from them. If you don't, you actually really need to understand these base 64 values. But not anymore, because I want to introduce today a new open source project. It's called Smart Home Manager. It's published since today morning, and it gives you various things. First of all, you can control all brands with one package. All these three, right? It has auto-discovery mode. No sniffing network anymore. Just like put the package, put the config file of the package, it will sniff the network for you, get the IPs of the devices. So while it's important to know how Wireshark works and sniffing works, but this time you can just use the package. It has first-class TypeScript support. Package is written in TypeScript. It has TS docs, so you can go through the whole package, through the whole classes in package. It's human-readable device API abstraction. I don't know actually if it's human-readable. I can read it, so I don't know. You say if you can. And it has access to low-level device interactions, meaning even though there are APIs that abstract things, we still can get access to the low level and actually send bytes and this kind of stuff. So now creating GraphQL, even GraphQL-powered bridge, it's really simple. And let's take a look at the demo. Here I have an app which shows me all light bulbs that are configured for my home, but only one is available, and it's Gant's light bulb. He brought light bulb for the States. So unfortunately, he is in that hole, but later on, say thanks to him. And I can just turn it on, turn it off. I have this group, which is sensors, and this groups, which is groups group. Actually, with the Philips Hue, you can define specific groups, and with these groups, you can control various scenes. You can say, OK, I have 3 light bulbs in the bedroom. This is this group called bedroom. I actually have it here. Or in corridor, you have 2 light bulbs. You can define these groups. I also have Wemo here, which I can turn on, turn off, right? So the fun part about Wemo, about the smart plug, I mean, I want lights, right? But I don't have the light bulb, or it's even LED. I cannot put a light bulb there. So I just plugged it in a smart plug, and it just works. And we have Magic Home, which is Chinese light bulbs, but they are fancy. And we can change colors. And we can even dim brightness. And you see, the Chinese one, they don't know that like the colors are not really dimmed. So as I said, sometimes it's reliable, sometimes it's not. For like full colors, it's reliable enough. So, and we can turn it off, or we can party. And no, party didn't work. Let's try now. Yeah. And we have a party. We have all these light bulbs working, right? So that's cool, right? I think, at least I think it's cool. Yeah, so that was the demo. Probably it will just, I will just turn it off. Party will be later. And let's see how it looks like if we check our bridge. We can, this is the actual bridge, so we can get hues. We run query, GraphQL query on the bridge, and we get all hues data. Or we can, what do we want to do? We want to disable the light bulb, right? Too much light. Where it was? Ah, it's a different one. I think it's 5. Yeah, it's 5. So I can toggle state from here, and eventually the application works with this bridge. The cool thing about the bridge, you can put it on any device that supports Node, meaning a Raspberry Pi. It can run on 8, it can run even on Raspberry Pi Zero or any other board that supports Node. And even if you have a desktop computer that is in your room and you don't want to buy a Raspberry Pi or something, you can just run it as a server, and it just works. We can check, for example, discover various Wemo devices, which it's an old one, sorry. We can set binary state, for example, for Wemo. Let's change state to 0, and we see it turned off. So we can interact with this bridge. We can debug the things via the bridge even before we dive deep into working with GraphQL bridge. And hey, you just work with the GraphQL, right? It's like nothing native core or something like that. You just work as you used to work even for web. And actually, you can even build a web app using this bridge, but it will be like web app only for you on your desktop computer, so not really, there's no really point for that. And let's take a little look at the code. Let's how we create this bridge. So we need to require isomorphic fetch. The reason for that, because the package uses under the hood fetch API, and we're running in Node environment, so we require it. Then I used for this demo GraphQL Yoga, which is an amazing GraphQL server. You can use whatever you want. The package doesn't depend on GraphQL even. If you want REST API, go with that. You can do that easily too. Then I require Smart Home Manager, which is the main point of the package, devices and pattern lists. Devices and pattern lists are under the hood, they are enums. Devices are basically the types of these 3 devices. Currently supported only 3. Later on, probably more. At least I need that for my home, so I will support more. And pattern list, you've seen that flickering thing with the Chinese light bulb, right? There are a list of patterns you can use with this type of light bulbs, around 11 patterns, and it supports all of them. Oops, different slide. Yeah. I require, if I want to enable auto-discovery mode, I need to require SSDP client. There is, and I pass it to Smart Home Manager. The reason I pass the client from outside is for later on support for running the whole thing on React Native, and instead of using Node environment, using React Native SSDP, so I will be able to pass it from outside. Manager looks like this. I start a new instance of Smart Home Manager, and I pass an array of configuration objects of type of specific device and with options. For Philips Hue, for example, yes, there is a specific option called username. You can pass it if you have it. If you don't, you can just use the API and use it through Smart Home Manager to get this username. And here you see I can pass IP. If I enable auto-discovery mode, it doesn't look at this IP at all, and it just gets the actual IP it discovered. But if you don't want auto-discovery and you have the IPs of every device, you can just pass them, disable auto-discovery mode, and it will work in the same way. For Wemo, I have to pass setup URL again if I don't enable auto-discovery mode. Remember the SOAP round trip with the messages? So the second response was the setup XML, and it got all the services name Wemo uses, so it's essential for Wemo to work. And unfortunately, I told you there is well, the trick is the package, but there's another trick. Chinese light bulbs are undiscoverable. So we need to get the IP of the Chinese light bulbs. We cannot auto-discover. Reason for that is under the hood package uses UPnP discovery, and these devices are just hard-coded IPs inside the brand app. So you just need to figure it out by the steps I showed you before. And then we have on ready callback, which triggers when everything ready, everything is set up. And as you can see, I can pass auto discovery true, and the package will discover everything automatically. And also, of course, pass SSDP client. Then I have various queries, right? I've showed you in the bridge, we have queries, we have mutations, we use GraphQL here. So I have a query called supported devices, which gives you all device list. For example, if you want to enable auto-discovery, and then you want to choose which devices you want to support, you can get this one, and you will get back the whole list of IPs, of set URLs, all configuration you eventually want, or if you want to filter it, you can get it. Get hues, for example, works in the following way. We have the manager that we created at the beginning, right, by passing configuration file. It has controllers object. On controllers object, we have 3 different controllers: Philips Hue controller, Wemo controller, and Magic Home controller. You will see in later queries, the pattern is similar. You see I have get hue state, which is available in Philips Hue controller. And for example, for Magic Home, it's the same pattern: manager, controllers, Magic Home controller, right? So you see it looks pretty same. And for example, for mutations, I pass what function requires. In this case, for hue, I need an ID and I need a specific state. It keeps repeating it, like the same pattern. Set binary state is for Wemo, for example, magic color with brightness, and this is party. Setting pattern, you see pattern list, 7 colors jumping, so even descriptive naming. And yeah, I just start the server, and it runs on port for 4000. I mean, you can choose whatever you like, create your own server, use any technology you want. If you're in node environment and running it, it will just work. Or won't, I don't know, you tell later. Let's see how we deal with that from the actual application. So in our application, I use the Apollo client for interacting with from React Native to GraphQL server. So I use the Apollo provider from React Apollo, and I create new client. The client has URL of the bridge. This specific URL, you may ask why it's not localhost, right? So I run the bridge on localhost, why I have this URL. If you, for example, choose to run on Raspberry Pi, it will obviously have different URL, right? So you will enter here the URL of the actual bridge. And then I register my light controller application and basically bootstrap the whole application. I used here for the UI, I used a really cool package by CallStack called React Native Paper. So check this out too, it's really cool. Then for queries and mutations, I use query and mutation. We have hue component. Right, let's get back to an app because so we won't be lost. So this is the hue component. The whole tab is the hue component. So let's take a look what's inside. We query for get hues. Remember the bridge? I triggered this query and I got the whole list of light bulbs. That's exactly that. If you're not familiar with Apollo, basically you can think about that you request something from GraphQL endpoint, and you get the result. So if you don't want to use GraphQL, you can use here start fetching data from some specific endpoint you define. In Apollo client, it uses render probe under the hood, and we can actually define if we in loading state or in error state. And if we are not in error state, we basically map over all our groups of lights, which are lights, sensors, and groups. And or we paste the whole thing, like the whole configuration file here. Or we actually, if we have lights, we have all this data here and working light bulbs. Yeah. So this button, by the way, it was active toggle button. It calls mutation. Toggle hue state mutation passes ID. This, in this case, it's 5 and passing a state. And you've seen the light turns on. By the way, I will yeah, let's check this out. By the way, I can, instead of toggling the state on, I can even change lights. So I can change hue of this light to be, for example, that. Hue. Yeah, 5. Thanks. And you see the color change, so we can change to that, and colors change here. So we can also control lights. Hue has a very particular system of lights. It doesn't use RGB, it uses its own system, so it basically values from 0 to 65,000 based on the specific graph. You can check the whole range of lights on Hue website, Hue API website. Let's get back to the presentation. So here I triggered the state, right? And I just toggled the variables ID. You've seen the ID 5. And the state, I changed it from switched off to switch on. For Wemo component, first of all, because Wemo need to get this setup URL, and because it needs to be actually connected, we need to call Wemo connect. This is essential for working with Wemo specifically. You call this mutation, it connects, and then you can query it, you can change states, this kind of thing. So when this mutation is executed, meaning we are already connected, I connect with component mount, and I have the mutation set state mutation, which you've seen also in the bridge, changing state from being 1 to being 2, meaning like triggering, turning it on or turning it off. And it's the pattern continues, right? So it's the same pattern. You have query, you have mutations, you have the bridge, you can use GraphQL or you can use REST or whatever you want. So you see the same one, and mutations, toggle magic home state this time, and we can toggle the state. You see the API is similar, right? We triggering one brand and then another brand, and it simply works. So there is a specific roadmap for Smart Home Manager as I planned it. So Smart Home Manager supports subscription. So you can subscribe to state change on the device itself, and you can log the state change, do whatever you want if state has changed. Currently, it's not supported along the whole API of all 3 devices. So the first thing that I'm supposed to do is to change that. Need to bump up test coverage. I don't have all kind of Philips Hue devices, Wemo devices, and Chinese light bulbs at home. So testing on physical devices when we talk about smart home is really essential. You cannot emulate, like, you cannot create unit tests for the specific device, especially when we talk about low-end technology like the LED strips. It works over sockets, so we need to test this with actual devices. Philips Hue API is huge. Currently it has all the basic functionality, but Philips Hue has also authentication API and remote API. You can you can connect to your home from remotely, you can authenticate yourself, etc. I really enjoy using GraphQL, so the next thing is to add GraphQL helpers. You've seen that queries I passed, instead of using, like writing them down manually, requiring GraphQL helpers and merging schemas, that will be a really good step to improving the package and improve documentation. Currently, let's check this. Currently, this is the package. The documentation explains how you configure things, how you do the discovery, the whole reverse engineering thing. I told you the auto discovery. It has several examples, and I told you it's first-class TypeScript support. So it has the whole TypeScript docs, so you can check all enums that are out there. This is, for example, pattern lists that it supports, all devices. Currently, it's 3. I plan to support more. So still, it needs improvement. So this is the really crucial step. And I really welcome everyone to contribute to this package or just try it out. And even if you don't open PRs to this package, but say, hey, this didn't work and that worked, this is really helpful for the package maintenance. Thank you very much for being awesome. This is the, thanks. This is the GitHub repo of the presentation, and with all examples I showed you, so you can just browse the code, check it out, and see how it works. Thanks.